Hello, welcome to my class. In today's physics class, we are going to study the most haunting part of physics. What? The snake. Some of you are thinking, what the snake? I have accustomed from many students that they actually try to make this as a snake that which can bite in exam. This is nothing but integration. This is a sign of integration. We are going to understand that one today. So what is integration? So let us find out. So integration can be understood like this. Integration is actually a summation of all the probable patterns which might lead to a larger or meaningful concept. So how it is it? I think this is a very bit confusing for you. So just let me clear it out. Just think of this in a very common and easy way. We do integration on a daily basis. Now if you are going to ask me, sir, how we do integration on a daily basis? Just think of this thing that each and every small bricks, when they are integrated, or you can say when they are summed up in a logical pattern, can lead to a large building. Similarly, each and every small personality traits, when integrated, can give you the character, say for you, or it can for any person. Similarly, when you write anything, small letters integrated to form words, words integrate to form sentence, and these sentences are integrated to form paragraphs. So we are performing integration on a daily basis, right? But it is just that we don't take a notice to these things. So let us understand integration very conveniently and more precisely. Like differentiation, we are also engaged in integration on a daily basis. Yes, we are doing it, but we don't take a notice to these things. So mathematicians, again, what did they do? They took a notice of these things. They turned the common sense into an important tool which can be used to understand physics a lot better way. So what did they do? So in this way, integration became a very important tool to understand physics better way. We are going to use integration on a daily basis for anything to understand physics, especially in class 11 and 12, not only 11 and 12. You are going to use integration forever if you wish to carry on with physics or science. So come, let us not waste any more time by talking all these things. Let us jump into integration at this moment. I hope the concept of function is very clear to you. If you have really any problem for the concept of function, if you need to understand concept of function, what is function and what is differentiation, what are the small differentials or the small change of x with respect to y, don't forget to refer to this video and you are going to get a precise knowledge of differentiation. So come, now we are going to understand integration in a lot better way. I am just trying to explain how integration we use in physics. So for this I have to draw a graph. Suppose this is a time axis and this is a velocity axis. And what I am trying to let you understand, just think of that you are moving from city A to city B. So while you are moving from city A to city B, you are moving with different speeds at different intervals of time, right? That is quite evident. In some part there is very congested, you have to move your car very slowly and carefully. And in some parts there is a lot of space where you can ride your car on a high speed. So we are going to try to understand each and every interval. We are going to try to understand each and every interval how the car velocity is changing. Suppose I can say like this, let v1 be the velocity of car at del 1 interval, del t1 interval. Let v1 be the velocity of car at del t1 interval. And similarly, v2 be the velocity of car at del t2 interval. So what I am trying to explain to you, I am just going to draw this over here. Suppose this is I am just trying to plot the velocity. What is the velocity of my car at each and every time interval? Suppose this time interval may be del t1, this time interval may be del t2, this time interval may be del t3, this time interval del t4. Now these intervals are going on like this. Okay. Now at del t1 our speed was like this. Suppose like this, at del t1 speed was like this. At del T2, that is, you have just started your car. So speed of your car was like this. So this is our V1. At del T2, you have increased your speed. So this was our speed at del T2. And del T3, you have increased your speed. So this is our velocity at del T3 interval. So in this way, if I go on plotting till up to del Tn, suppose if I go on plotting till del Tn, so we are going to get a lot of patterns, right? We are going to get a lot of patterns for how my velocity was all over my trip, right? So this is clear to everyone. So this is nothing. I am just trying to plot how my velocity was at different intervals. What is the velocity of my car at different intervals? That is del T1, del T2, del T3, and dot 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 del Tn. So what I did, actually I divided the total time taken to move from point A to point B, or you might say city A to city B in n intervals. So we were moving from city A to city B, right? So this is what it looks like our velocities at different time intervals. So here we get a complete knowledge of velocities at different time intervals, right? So from this pattern you can draw a curve also, right? From this pattern you can draw a curve also. So this is very important, very easy. Actually, you have already done all these things in your previous classes, in your junior classes, I know. You have to draw this type of diagram. From here, important concept of integration comes. How? That I am going to show you. So suppose if you try to understand how much distance my car traveled at del T1 interval, so S1 be my car traveled at del T1 interval. So that will be V1 into del T1, right? S1 is the velocity, S1 is the distance moved at del T1 interval. So S1 I can say distance moved at del T1 interval. So at del T1 interval, distance moved was S1. So S1 will be V1 into del T1. Why V1? V1 is the velocity. While I was moving within del T1 interval, my velocity was V1. So S1 will be my distance. So S1 distance will be V1 into del T1. So this is clear. Similarly, I can write S2. S2 will be, I don't have space over here. So S2 will be del V2 into del T2. S3 will be V3 into del T3. Now what is S2, S3? S2, S3 are actually distances that my car moved at del T2 and del T3 intervals respectively. Now if I am asked what is the total distance I have traveled, what is the total distance I have traveled, what I am going to do? I will just integrate, right? I will just integrate. That is, I will just try to accumulate, or you might say, I will try to do a summation. So what is summation? So I am going to do it like this, like total distance S will be, so total distance S will be what? S1 plus S2 plus S3 plus dot 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 plus Sn. This will be my total distance. So ultimately I can write over here as V1 del T1 plus V2 del T2 plus V3 del T3 plus dot 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 plus Vn del Tn, right? So this becomes my total distance. So this becomes my total distance, right? So ultimately what I did, just try to understand, I have actually tried to find out my total distance by doing summation of each and every small distance I have covered within del T1, T2, T3, T4 dot 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 del Tn intervals, right? So we are just trying to find out the areas of all these rectangles. So how we are going to find out areas of all these rectangles? Here V1 into del T1 gives area of this rectangle, V2 into del T2 gives area of this rectangle, again V3, this is V3, right? This is V3. So V3, this entire distance is V3. When you multiply with del T3, you get this area of this rectangle. So ultimately, we are adding all these small rectangles up to del Tn. So ultimately, we are trying to find out the area of the curve or area under the curve. Yes, I am going to explain this part more precisely. So before that, let us complete this part, what I was talking about here. Here, see, we have got total distance I have moved, that is V1 del T1, V2 del T2, V3 del T3, dot dot dot, Vn del Tn. So now what I am going to do? I am simply going to do summation. So summation of all this Vi del Ti. So this is our summation I is equals to 1 to n. So this is our summation symbol. So if we add all these small rectangles, or if we add all the small distances or displacement or whatever you say, distance, and there is a big difference between distance and displacement that I will explain you in the next chapter. So here I am just considering these are small distance, okay. So summation of all these small distance give us our entire distance. So this is a very plain and easy concept, that is, we are just adding each and every small distances, and that gives our total distance we have traveled. So what we are just doing, we are just integrating. This is what integration is, right? This is what integration is. But now why we use that integration sign? See, here velocity was very easy because you already know this is the velocity. But sometimes there can be you need to find a physical quantity which can be in this form fx dx, which can be of form fx dx. Now I know you are going to get confused with fx and dx. Fx is a function and dx is a small interval, right? So if we need to find out the total area under this curve, we need to do integration. We need to do integration of lower limit. You are going to do integration from lower limit to upper limit. This is it actually integration. Integration is actually a concept of summation of small area that forms under the curve. Okay. So I hope you have understood, but still I am going to explain this part a more bit. So for this I need to wrap this board over here. Suppose I am defining a function. So what is function? You all have the idea of function now. So let the function is like 3x plus 1. This is the function. So if you put the values of x, you are going to get different values of fx, right? Now suppose x is varied very small, within very small intervals. That means if we vary x with very small increment, that is dx increment. We are going to vary x with very small increment. Suppose you put some value of x. Now at the next moment you are going to increase the value of x by x plus dx. Okay. So if we do this, what we are going to see? So we are going to understand this part in graph. So this is our fx curve and this is our x curve, right? So what is happening over here? Just try to understand this part. This part is very interesting also. See, for a certain value of x over here, I have got of some value of fx. Now if you are going to increment, that is a small increment dx, this fx will change. Now this fx might change like this. So this small increment of dx is going to give you the value of fx. Again it will change, right? So if this dx is very small, if the dx interval is very small, you are going to get an idea that this rectangular width will be very small. So ultimately, even if this part happens to be the rectangle look like this, but if this is very close, if the width of this very close, what we are going to understand? If this width becomes very close, this will form a very narrow rectangle, right, like this. So similarly, we have got a value of rectangle. We have got a rectangular value over like this. We have got a rectangular portion like this, fx dx. Now we get a rectangular value over, or we can say we get a area of this rectangle. We get a area of this rectangular portion, right? Fx dx. So fx dx gives us this rectangular portion. Now again, after certain interval, now if you think of this increment dx over here the dx may change. Why here the area may change? Understand this part. Whatever the value of fx, what at this point of x, that might not be the same at this point of x. Why? Suppose if I have put over here, suppose if this point was x equals to 1. Suppose if this point was x equals to 1, then if you put x equals to 1, you are going to get the value of 4. But suppose if we put x equals to 5 here, over here, we are going to get the value of fx as 16. So fx may change at different position of x. So if fx change at different position of x, so the rectangular area at different position of x, that will also change. So if I have to consider the rectangular portion over here for at this portion, fx will be near like this and dx is like this. So this area becomes a different, right? Now if we need to find all the areas from starting from this point to a certain end point, then we have to know all this fx dx part. We need to know all this fx dx part. Fx dx means all these areas. So ultimately this fx dx gives us area of a small rectangular portion. Now integration, this sign integration means we are adding all those small rectangular portions to give a larger physical quantity. We are adding up, just simply addition. Now you are going to ask me, sir, why are you not adding simply like algebraic adding? See, this function varies differently, right, at different position. So we just cannot add this like this. For this we have to use some formulas. Now from where these formulas came? These formulas actually came from this concept only. This summation concept only, these formulas came. Now we have already got these formulas. We are going to use this tool to understand physics better. So how we have got these formulas, that is a subject of mathematics. You can refer to mathematicians or your mathematics teacher. But I am a physics teacher. I am going to explain you how to use these tools to understand physics better. Okay. So if we do the integration from this portion to this portion, we get the entire area of this curve, right? So if this entire area represents any physical quantity, so then if we know the tools to use the integration, that will be very easier for us to understand. So let me give you another example of like this. Just try to understand. Formula of work done is F, force into displacement, right? Force into displacement. Force into displacement. I am writing x as displacement over here because there is a reason. So just think of like this. I'm giving you a box. I'm giving you a small box and I tell you to move this box from one portion to another, or from point A to point B. So at different point your force will be different, right? So at different point the force you are exerting to move the block, that will be different. So if your force is different at different points, then at different points your dx will also be different. So at each and every point you have done a different amount of work. With different amount of force you have done different amount of work, right? So if I plot a graph like this, this gives our force and gives our displacement, that is x, at different point, this is a dx I have given over here, this much amount of force F. So ultimately area of this small portion will be how much? Area of this small portion will be F dot dx. F dot dx, this area of this small portion is F dot dx. So this is a small work I have done in dx distance while moving the block within dx distance. So small work is dw. dw means a small differential work. Differential work means a very tiny amount of work I have done. Now if I have to know that how much work I have done to move it from point A to point B, what I am going to do? I am simply going to find the total work will be integration of all these fx dx from point A to point B. Simple. Integration is simple. Now why we are doing this integration? Because its force is varying at different points with change with x, and we need to know this physical quantity f dx, that is the total curve we are getting or the total pattern we are getting, and we need to understand the total area under the pattern or under the curve we are getting. So ultimately integration is nothing. Integration is we are trying to find out the total area under the curve. See, here fx can be like this, at another interval f can be like this, force can be like this, another interval force can be like this, another interval force can be like this. So this giving me a pattern, right? This is giving me a curve. So we are trying to find out, we are trying to break down this curve into each and every small interval, and we are trying to add all the small differential work we have done to move the block from point A to point B. So this is how we use the concept of integration to understand physics a lot better. So now I am going to write over here some important formulas that you need to mug up, you need to learn, and you need to also know how to use these things. Now I am going to show you how to use these important tools to understand physics, how to use these formulas. But in mathematics you have to understand in more depth wise. There are many ways to solve integration by parts, substitution, partial fractions. There are a lot of methods to solve these things, but I am going to explain you only those parts that you need. Okay, so let's our first formula we are going to learn. This one is integration of x to the power n dx. Suppose if you have any function where this is a function of x and this function is changing with small proportion dx, that is this the fx dx part, and your fx is x to the power n, then how you are going to use this formula? So this formula gives you result like this: x to the power n plus 1 divided by n plus 1. Now if you have lower limit as a and upper limit as b, then you need to put lower limit as a and upper limit as b. Now how you need to evaluate this? You need to evaluate this, that you have to put b in place of x, b to the power n plus 1 by n plus 1, minus, again you have to put this value of a in x, a to the power n plus 1 by n plus 1. So ultimately you are getting 1 by n plus 1, b to the power n plus 1 minus a to the power n plus 1. So this is it. This is how you evaluate this kind of functions. So here actually this part is representing your fx dx part. This part is representing your fx dx part. Now this here x to the power n is your fx. Now if you have any function which is like this x to the power n, and now this the dx is a small differential, there is small increment, with small increment we are increasing, then you have to evaluate this kind of functions using this formula in this way. So let us take an example for this. Suppose we are given a function fx equals to 3x square plus 2x plus 2x, like this. Then okay, plus we are given a function like this. Now we have been told integrate the function from point from x equals to 1 2x equals to 2. You have to integrate. So what we have to find out? So integration of this will give you like this fx dx. So you put the value of fx. So here you get 3x square like this. Now upper limit and lower limit will be 1 here and 2 here. Now you integrate each and every portion. Now when we are integrate this portion, we are going to write like this 3x square dx. Now see, this 3 will not take part in any function. Because why? Because 3 is a constant. With changing x, with small change in x, this 3 will change. So this is a constant part, this will come before integration. So when we are going to integrate it like this, similarly 2 will be done like this, x dx from 1 to 2, and here there is nothing, so this will be 3 dx from 1 to 2. Okay, so here this will become 3 x to the power 3 by 3 1 to 2. Why 3 by 3? X to the power 2 plus 1 divided by 2 plus 1. I have just told you the formula. X to the power n dx will give you the result x to the power n plus 1 by n plus 1. Similarly, this will become 2 x to the power 2 by 2. Put upper limit, lower limit, and here there is nothing, only dx is present. Since only dx is present and nothing is present, then we can understand this part as x to the power 0. We can consider here x to the power 0. Since with 3 there is only dx and nothing is present, so we simply write the one here x to the power 0 plus 1 by 0 plus 1, and 3 comes outside, 1 2. Here we all have a portion x, we all have x over here in these 3 terms, but here at term 3 there was nothing related to x, only there is integration of dx, right? So here we can understand this part as x to the power 0. So if there is x to the power 0 means 1, anything to the power 0 is 1. So we put over there x to the power 0 and then we integrate, we get x to the power 0 plus 1 by 0 plus 1. Okay. Now if we integrate this, what we are going to get? Tell me. We can cancel this 3 and 3 because this 3 is a constant. We can cancel this 2 and 2. This becomes constant, this becomes only 3. And here we get, since I don't have any space over here, here we get 2 cube minus 1 cube, right? Plus, what will be this one? 2 square minus 1 square, plus that there will be 3, 2 minus 1, right? So if you evaluate this, you are going to get the answer. So this is how you need to use this kind of tools. You need to use this formula in integration to do this kind of formulation or this kind of numericals in physics. Okay. So I hope this part is clear. If you really have any problem regarding any part in physics, you can directly text me in Instagram, or you can also put your mail. The mail ID is given in the description. Just go and mail me. If you have any problem, you can also write in the comment section also. I'm definitely going to reply you everyone. Okay. Now I am going to give you some more formulas of integration. Just note it down, and if you need to use anything while we are going to understand each and every portion in physics, I'm definitely going to explain you how to do those numericals. Okay. Here I have written this formula, this 6th formula. I have already explained another formula in this part again. So here see, if we integrate a dx portion, only there is dx, we will understand that there is a x to the power 0. X to the power 0 means 1. So if we integrate x to the power 0, we are going to get x only. Now if you integrate integration of sin x dx, we are going to get cos x. Integration of cos x dx, we are going to get sin x. Integration of 1 by x dx, we are going to get log x. And similarly, if we integration of e to the power x dx, we are going to get e to the power x. And here integration of sec square x dx, we are going to get tan x. There are more formulas of integration, but these formulas are important. Now I would like you to please note it down, these formulas. If you need any kind of any help from these formulas, you can avail anywhere from this video, or if you note down in your copy, then it will be a much easier for you to understand. So that's it. I would like you to remember all these formulas because they will be necessary for you to understand physics a lot better way. Okay, so thank you for today. Thank you everyone, and please, if you like this video and if you like the content of my channel, please don't forget to subscribe and like and share this with your friends. Okay, so thank you for today.